So some of this is fairly basic, but it's going to move pretty quick into more of the carrier Ethernet standards. And it's always good to have a refresher on this just because your customers are the kind of people that are going to challenge you on some of these technical points as you go along. So just a quick brush up on that. So really the training objectives is fairly concise. Understand how the basics of Ethernet technology works, and then how Metro Ethernet as a carrier service is delivered as opposed to the LAN that we're having trouble with in the room today. And then become familiar a little bit with what the MEF is doing and what certification means, and that's the kind of thing that's important to be able to express to the end user, because an MEF certified service really means that you have carrier-grade, reliable Ethernet offering. So we'll talk a little bit about the network elements, the basics of Ethernet, also the different standards that are behind that, the nuts and bolts inside Ethernet itself, so how the frames actually look and how does media get transmitted. And then we'll talk about the Ethernet services that you're offering to your customers in terms of E-Line, E-LAN, and sort of VPLS type private LAN service. And then Ethernet OEM, which is a subject that's very important in itself, operations, administration, and maintenance. And we'll try to keep this getting too technical, but these are the kind of things that really help if you want to talk to the end customer. But on a basic level, really, when Ethernet was defined, they broke down the different elements that could communicate in an Ethernet network down to a data terminal equipment, which is really the receiving aspect of the data or transmitting aspect, and then the data communications equipment, which is normally considered the hub or the switch that's actually passing data between these devices. So in the most simple network, this is basically how Ethernet was developed to allow different computers to talk to each other. And Ethernet is unique in a way that it's all point-to-point connections from a logical perspective. So whether or not you carry this over a SONET ring, every device sees each other as an endpoint, point-to-point, and communicates point-to-point. So these were the basic topologies that were originally invented for Ethernet back when it was originally defined by the IEEE. So point-to-point connections and then a LAN connection. And these extend today to the metropolitan regions and to your business services offering and your backhaul offerings in E-Line connections, which is the MEF term for that, or and then the E-LAN connection, which is also known as Ethernet Virtual Private LAN Service, or VPLS. And we'll look at that a little bit in more detail. There's also a ring topology that's being deployed by providers who go pure Ethernet across a large service provider backbone, and that's usually managed by RPR, which is resilient packet ring topology, which allows you to have protected optical paths in your SONET network or pure Ethernet network, depending on what you're using to connect it. And this really provides the protection, switching, and recovery times, like the 50 millisecond recovery time you need to offer a carrier-grade service. In terms of basic networking hardware, typically Ethernet is controlled by an Ethernet switch, and we'll talk a little bit about the network layers, but the Ethernet switch really runs at the MAC address. And if you're working in an IP environment, which is one layer higher, then you need a router that can actually translate the IP addresses to be able to connect to the appropriate Ethernet port. So where does Ethernet fit in terms of the model? And we've seen this stack often in the SONET, in describing SONET and so on. Basically, the three layers that are most important to us in an Ethernet world is the physical layer. So if you're connecting over a fiber, microwave, PON connection, or cable, or just copper. Then the media access layer, which is and the media access client, so the MAC client, this is like the IP address for Ethernet, and that's running at what we call layer 2. So you'll often hear people referring to layer 2 instead of Ethernet and interchanging those two together. And then above that, you have the network layer, which is considered in most networks today as the IP layer. So you have things like TCP/IP, and you have UDP for real-time communications. And that's all happening at layer 3. And then you have the port layer, I guess you'd call it, which is the layer 4, where you specify which port, UDP port or TCP port, you want to transmit the data. So that's kind of the structure of this. And this is based on the 802.3 model from the IEEE that have been basically extending that simple LAN model further and further into the carrier space over the past couple of years with cooperation with guys like the MEF. So what are the basics of 802.3? These are just the real basics of what Ethernet is. Media access is based on something called CSMA-CD, which is a collision sense, media access, and collision detection, which means that as packets try to get broadcasted in